Hi everyone, this video is on exercise 9J question 13. At time t seconds, the surface area of a cube is a centimeter squared and the volume is v centimeters cubed. The surface area of a cube is expanding at a constant rate of 2 centimeters squared per second. Write an expression for v in terms of a. Okay, so first, let's see what we have and just break down question into smaller and easier parts. So first of all, the surface area of a cube is mentioned. Let's say the surface area of a cube is A, and also let's say that if you have a cube, then its length is just L. So that means the surface area of a cube is 6L squared, right? So this is the surface area of a cube. And also volume is mentioned, so volume of a cube is equal to L cubed. Okay. Now the next thing that is mentioned is that the surface area of a cube is expanding at a constant rate of 2 centimeters squared per second. So this is giving us the rate of change of the area, the surface area of the cube, or basically dA by dt is equal to 2, because this is just the rate that is expanding at, and it's positive, so we don't have any negatives here. And now for part A, we want to write an expression for v in terms of A. Now part A is not even about forming a differential equation, because if you want to write v in terms of A, it's just basic algebra, right? So for example, A is equal to 6L squared, we know that. Now what we can do here is simply write L in terms of A and then plug that into in the equation of v, basically. So we can divide both sides by 6 to have L squared and then take the square root, which gives us L is equal to a square root of A over 6. So obviously length is always positive, so we don't have negative. This is L in terms of A, and then we can substitute this into the equation of v. So v is equal to L cubed, which means v is equal to square root of A over 6, then cubed. We can also write this in terms of fractional powers and have this as A over 6 to the power of 3 over 2. So both of the forms are fine, and we can just use the one that is easier. So A over 6 to the power of 3 over 2. And now for part B, we need to find an expression for dv by dA. So here the important thing to note is that we have already written an expression for v in terms of A. So we have from part A, v is equal to A over 6 to the power of 3 over 2. And now we want to find dv by dA. So that's basically differentiating this expression. So dv by dA is equal to 3 over 2 times 1 over 6, because it's just a chain rule, A over 6 to the power of a half. And now we can simplify this. So here the 3 cancels out with this 2, and we are going to get a fourth times A over 6 to the power of a half. So we can leave the answer here, and so this is basically an expression for dv by dA, and that's going to be useful for part C. So in part C, we want to show that dv by dt is equal to a half times v to the power of a third. So dv by dt is equal to, in questions like this, we always need to have 3 parameters to form the chain rule. And obviously if the question is about the time, if the time is an element in the question, for example here is, in this case, the question is basically telling you the amount of volume of surface area at different times. So t is an element in this question, so we need to have the time, and then usually the next two, the other 2 parameters are the things that are given to us in the question. In this case are volume and area. So the point that I'm trying to make is that in the chain rule, we need to form a relation between these 2 parameters in a way that is useful to us. So since we want to find dv by dt, So we need to have dv in the numerator, and maybe dA can be a good choice for the denominator. Therefore, we can have dA here on the second numerator and dt on the denominator, because in this way the two dA's will be cancelled out, and then we are going to have dv by dt. So we have dv by dA from part B, so that's a good sign. It's here. And now we want to see what is dA by dt, but we basically, we have found dA by dt from the previous part, right? That just simply from part A. Actually, it wasn't from part A. I just wrote that here, but yeah, in the question it's given to us that the surface area of the cube is expanding at a constant rate of 2 centimeters squared per second. So that's dA by dt. Now we can substitute the different values. So dv by dA is equal to a fourth times a over 6 to the power of half, and dA by dt is just 2, so we are going to get a half times a over 6 to the power of half. But remember that the form that we are trying to find is a half v to the power of a third. So let me remind you that a crucial thing here, volume is equal to L cubed, and if you want to write L in terms of V, it's going to be the cube root of L is equal to cube root of V. Okay, this is going to be useful here. Also, there was another thing I forgot to mention. The surface area is equal to 6L squared. So we can here substitute 6L squared into A, because that just surface area divided by 6 to the power of half, and then simplify this. Because if you simplify, we are going to get a half times L squared to the power of half, which is basically a half times L. And on the other hand, we know that L is equal to the cube root of V. So this means a half times the cube root of V. And if you want to write this in fractional powers, we can write as a half times V to the power of a third. And this is exactly what we wanted to show at the beginning. So a half times V to the power of a third. Okay, that's it for this video. Thank you for watching.